This is section 5.8, part B. We've been looking at comparing exponential models with linear models. They both have constant rates of change, right? Linear models had a constant absolute rate of change, and exponential models had a constant relative rate of change, usually expressed as a percent. We're now going to throw the quadratic models into the mix, or perhaps even other polynomials. So thinking quadratic, cubic, quartic, and saying in this particular example here, in the next two, I'd like us to choose specifically between exponential and quadratic, taking into account both the shape of the curve as well as the end behavior that we might predict. The increasing or decreasing behavior of an exponential function, right, could actually be half of a parabola potentially, right? Or it might just continue to slowly go down. So sometimes the best way to decide between quadratic and exponential is whether we expect something to go back up or just to kind of continue to level off or go down just slightly. All right, so one more time here. I guess I could have put the sketches down here. Exponential growth. Looks like this. I'll do the growth since I did the decay up here versus quadratic, which might look more like this, right? So again, same as I was illustrating up here, kind of depends on what you think the end behavior does when you choose between them. All right, in the problem below, the data is actually intentionally a bit older, only goes up to 2004, and we're going to go ahead and see if we can predict what's going on, both because of the shape, but also because of what we maybe know already a bit about where the end behavior was going to go. So we have revenue from sales of blank audio cassettes from various years, and it's shown here in the table. You can see for the years 2000 to 2004, and we saw this decline in sales. Okay. We're supposed to choose either quadratic or exponential model, define our variables, and then predict the sales for 2010. So I'm going to go ahead and start, and let's just say T would be years after 2000. And R is going to be our revenue in millions. And that means my T values here go from 0 to 4. So we're going to put that data in. And let's see what it looks like. There we go. All right, so I could see this as the beginning of an exponential decay function, right? It could potentially just keep on getting smaller and smaller. That's certainly reasonable. Or I could also see it as sort of half of a parabola if I think it's going to come back up over here. Either one visually would sort of make sense. So now I want to think which seems like the better choice. From what you know about sales of blank audio cassettes, do you believe that that sales amount would have made a resurgence and come back up in recent years? And of course, I think we all know that that's not the case. Nobody uses cassettes anymore. Excuse me. People are certainly recording digitally, and so we would really expect this to continue to die away, not to come back up. So for that reason, I'm going to say I think an exponential decay model is a better choice than a quadratic model. So let's do that, and I'm going to use the AB to the T form. Looks like a really good fit. My R squared is 0.995 something, and so there are my A and B values. And so I'm going to say R of T is 161.782 times 0.788 to the t power. And I wanted to make the prediction for 2010, so I really want r of 10. I'm going to go ahead and type in my function. I might as well just let Desmos do the math for me here. I'm sorry, I wanted to make that to the t power just so I could see the match. Yep, I typed in everything correctly, and then we'll just do r of 10. Of course, I had it before as well, but that's just a little bit more normal way of doing things, I guess. And it looks like we'd be predicting about 14.9. So there is my function written out by hand. And there's our prediction for 2010, r of 10, 14.9, that was in millions of dollars. All right, let's take a look at another one. This is U.S. oil production for various years, and we are supposed to choose either a quadratic or exponential model for this data, again, making sure that we go ahead and define our variables.